And welcome. So, in this experiment, we are going to do uh, a hands-on practice on Arduino and Arduino microcontroller and the sensors and actuator. So here we are having Arduino UNO board with us, and this is a connecting cable, and this is LM35 temperature sensor. It is actually a temperature sensor that is having three leads and one, two, three named. One is voltage pin, and two is an output pin, and three is an ground pin. Okay, so this is a connectivity diagram. There one more actuator is there, piezo buzzer is there. So this is so called sensors, this is actuators. Okay, so practically speaking, sensors are the devices that are converting physical quantity into electrical quantity. I mean, temperature is a physical quantity. Temperature, displacement, velocity. Okay, so water level, light intensity. So these kind of so called physical quantities we can able to measure with the help of the sensors. This is a temperature sensors. Very good example we can able to tell in our automobile. I mean, in our bike itself, we are having odometer, right? Speed, actually it is measured with the help of a odometer. Okay, and it is actually converted into digital quantity, and it is supplied, I mean, it is given as an input to a microcontroller like this is a microcontroller, Arduino microcontroller. And in our bike itself, it is displayed in form of digital digits. I mean, in 7 segment display, or otherwise LED screen itself, it is completely displayed, right? So sensors are nothing but the device that converts physical quantity into electrical quantity. So actuator, that is doing in reverse, right? I mean, electrical quantity into physical quantity. Any form of physical quantities, like in form of visual informations, like light, sound, rotary movement, linear movement. So called physical quantities, it can able to activate, it can able to interact with the environment. I mean, the automation is in the need of some microcontrollers, sensors and actuators. Sensors actually interacting with the environment, and what is happening in the environment, that are all measured with the help of sensors, and that is given to the microcontroller. And the microcontroller is actually having a program like this. Okay, so it is written by the users, right, or the programmer. So based upon the program that is already fetched into the microcontroller, it is accessing the actuators. Okay, so this is how the an automation is working. So it is like our brain. Our human brain is actually the very big inspiration for the invention of this microcontroller. And we are also having these sensors and actuators in our body. Also we are having sensors and actuators, like our eyes, ears and skins. The entire body part is having plenty of sensors and actuators, like leg, hands, vocal systems. The entire systems is, I mean, in the human anatomy is having different sensors and actuators. And this is similar to our brain. Okay, what we are going to do is, we are going to do we are going to connect the yeah, there is a LED is there, it is also an actuator. Buzzer is a audio actuator. This is a visual actuator, light indicator, right? They produce sounds, so called, this is piezo buzzer, right? And this is a Arduino diagram, and I mean connection diagram. This is Arduino Uno, and where LM35 is connected over here. So in order to power on this sensor, we need a 5-volt power supply. The is Arduino can able to give 5-volt from this port. I will show the board now, right? So the LM35 is connected over here, the LED and buzzer is connected over here. So this is the program. Okay, let's we execute the program in real time. Yeah, this is our Arduino uh, board, Arduino Uno board, and wait a minute. Yeah, this is Arduino Atmega 328 microcontroller, and these are all the digital I/O ports, and this is analog I/O ports. So you can able to see like A0, A1, A2, A3 pins are there, and these are all the digital pins. Okay, there are two type of sensors and actuators, digital and analog. So whatever the LED which is blinking over here, right? This is a power up LED, and a separate 13th pin LED is there. Okay, so this is the 13th pin LED where I'm pointing out. This is the 13th pin LED, right? This is inbuilt, this is connected in inbuilt, and this is a piezoelectric buzzer, right? And this is the entire Arduino board setup, and this is the temperature sensor LM35, right? Okay, this is LM35 temperature sensor, and it is having three pins, right? Signal, VCC, ground, and it is connected via these jumper cables. And here there are three pins, okay, that is connecting 5 volt. Can you able to see this 5 volt pin, right? This 5 volt and ground, so it is being in red and brown color. So red and brown color is going here, and it is connected at VCC and ground. And this blue color connector that is connected over here like A0, I think, yes, it is connected. I mean, it is actually the incoming signal from the sensor. Okay, so this is the connectivity for temperature sensor and buzzer that is having two terminals, and red and black, right? Red and black. So red is connected at pin number 12. Okay, please wait. Yeah, pin number 12. Can you able to see this pin number? Yeah, pin number 12. Okay, yeah. Okay, yes, this is pin number 12. This is connected in pin number 12. Sorry. Yeah, this is connected in pin number 12. I mean red signal, red pin, and the black is connected with the ground. Okay, so the buzzer is connected, and I already showed the internal, I mean inbuilt LED, right? This is the internal, I mean inbuilt LED. This is quite off now. Okay, no need to connect this LED with the help of wire. That is already connected at the 13th pin, right? Okay, this is the entire setup whatever we see in our manual. Okay, this is the actual setup what we having here, right? So this is the code. Okay, so this is the code where we are going to upload. I mean it is already uploaded. Okay, this is the software called Arduino. Okay, so there is a Arduino software is there, so we can able to go to this icon, and we'll have a label like this, and we'll get a new file like this. We'll open a new file now. Wait, yeah, this is a new Arduino file. It is having two functions. Okay, void setup and void loop. It is having two functions. What is void setup? This is a function, okay, to declare the hardware informations. Okay, what all the hardware parts are there? Here we are having a buzzer and a temperature sensor, right, and an inbuilt LED. There are three different sensors, and the three hardware devices is there, right? So since it is a embedded programming, we must clearly declare the hardware informations here, and what should happen. I mean within the loop function only, the repeated actions must be expressed, right? So I'm having already the I'm having the code already now, right now. So yeah, this is my code, right? So where, please look at these declarations before the setup kind of file itself. Sensor pin, okay, integer sensor pin equal to A0, where I'm going to connect that. I'm just giving name, that's all. Okay, so sensor pin A0, 13 LED pin, 12 buzzer pin, that is already connected over here, right? So threshold, I'm going to measure the threshold of the temperature sensor. Okay, I mean sorry, I'm going to measure the temperature from the temperature sensor. If it is exceeded to 32, okay, 38, I'm have given here 38 because, okay, here there is 32 because our room temperature is 32. Okay, so in order to explain, I mean in order to give a demo, here I'm just setting the threshold as 38 because the room temperature is 32. Okay, the sensors and actuators are working in a way that it will measure the temperature, and if it is exceeded 38, the buzzer will start blinking, right? Okay, so these are all the initial declarations, and void setup itself, I'm going to initiate the sensor pin as input pin. Yes, of course, sensor is a sensor. This temperature sensor is the input for this Arduino, right? So temperature, I'm configuring my sensor pin as the input. So the sensor pin means on the top of all the commands I already declared A0 is a sensor pin, right? So the sensor pin is now declared as input, and LED pin is now declared as output. Buzzer pin is also output. We know that sensor is the input device, the buzzer as well as the LEDs is nothing but output device. Okay, technically it can also be called as sensors and actuators, right? So we need to start the serial communication, then only the data from this Arduino is has to be transferred to system, right? Then only we can able to see the results in this computer monitor, right? So we need a serial communication, that is serial dot begin, that is the command for starting the serial communication. We are using USB cable, right? USB stands for universal serial bus, that's all. Okay, so these are all the hardware informations, where the sensor is connected, where the buzzer is connected. So likewise we need to give the entire information to the Arduino program initially. So that is what we are doing, and also we need a communication also. Okay, we need a communication between serial, the Arduino. We are connecting temperatures. We are just adding this line. Okay, serial dot begin 9600, right? So very important part, the loop part, right? We are going to see what we have to do is we need to it is a cyclic process, like right from measuring the temperature from the sensor unit, and then we need to calculate with the help of this formula, like just it is a sensor data, right? It is so-called raw data. So from the sensor pin itself, it is a predefined API command like analog read. I'm using this command. I'm just measuring the analog value, the sensor value, and I'm just putting into LM data. I'm calling this value as a variable called LM data, and I'm declaring it as float, right? So the LM data is nothing but LM data divided by 1023.0 into 100 into 5. This is the process of converting the raw data into Celsius format, right? So I'm just printing serial.print room temperature is like this is the string printing, the entire line is getting printed, and then I'm printing this data, right? So I'm just printing this value, this converted voltage value is given here, and this is this character for degree Celsius, and actually now it is not displayed over here. We need to give an equivalent character, ASCII character for the degree later, right? So delay for every every 10 milliseconds, every 0.1 seconds, okay, right? This is 100 in terms of milliseconds we need to measure. So every 1/10th of a second, 0.1 second, it is getting data is getting printed. So this is if loop, if statement, right, where what we are doing is if the measured temperature is exceeding the temperature threshold, okay, serial monitor has to alert the users by printing this line, temperature baseline exceeded. Likewise it has to print, and it has to blink the LED as well as the buzzer pin, right? You can able to check the highlighted lines now. Pin high, LED pin high, buzzer pin high, LED pin high. So both the buzzer and the onboard LED is will be switched on, right? Then with the 0.5 second time interval, the buzzer pin as well as the LED pin will get switched off, right? So this is also having a separate 0.5 second delay. So this is a loop command. So whenever the the temperature is getting exceeded the threshold value, this blinking will happen, right? Okay, then else, okay, this is embedded programming, right? Once you switch on the switch on the device, hardware device properly, you should have a command for switch off the device also, or otherwise the device will be permanently switched on, right? So once you switch on the device, you should have the command, your program should have the commands for switch off the device also, right? So else command, okay, else means what? If suppose the threshold temperature is exceeded, means this will happen, okay? If it is not exceeded, it is lesser than 38 degrees Celsius, means automatically automatically this buzzer pin will get low and LED pin will get low, and then we are closing the functions, right? So this is the command, this is the program that was given here. So we need to do, in order to do this, already the port is getting connected. Go to the tools, okay, save the program, okay, usual commands like control plus yes, okay, then go to the tools and board, okay, it is selected as Arduino Uno, okay, and then also go to the tools and port, this is COM port, okay, right, then you need to go to this option like upload, okay. So once upload the code, so it will start compiling the code, right? After compiling, it will start uploading the code, right? So it is, the status is updated here, it is done uploading, right? And go to the top right corner, like it is, there is a serial monitor option is there, so it is called a so-called, it is output screen, okay. So it is displaying, right? So it is displaying like this, okay. So the room temperature is always 32, 33, like that, okay, it is measuring, okay. Now I am having a soldering iron setup, right? So I will show the screen now, okay. Okay, so the temperature is now nearly about 32 or 33, okay. There is a soldering iron setup is there, okay. We know that this is somewhat heat, okay. So I am placing my soldering iron nearby the temperature sensor, okay. Yeah. Our threshold is 38, I think, right? Yeah. You can able to see the temperature. Whenever the temperature is exceeded, that the data, the line we have already added, temperature baseline exceeded, that is also printed over here. You can see in the monitor, and I'm still having my soldering iron nearby the temperature sensor, and the LED is now blinking. You can able to see here. The red color LED is blinking, right? Okay. Under the blue color cable itself, you can able to see the LED is blinking, okay, and also the buzzer is also playing, right? Okay. If I am remove my the soldering iron, okay, the temperature is getting reduced, okay. It is still 40, 41. The buzzer is playing, right? Yeah, LED is blinking. 40, 39, 38, again 39, it is wavering within 38, 39, okay. Still it is above 38, 38.12, okay. Yeah, again whenever it is reduced, it is going below 38, it is, yeah, now, okay. I'll just cooling this, try to cooling this temperature sensor. Okay, this is the principle, this is the working principle, right? So with the help of this automation, we can able to monitor the temperature of a machine. Like if it is exceeded, it can be intimated to the technician, okay. So in the form of light and alarm. Thank you.